The purpose of this video is to review a set of procedures that you can use to convert a repeating decimal to a fraction. It seems like every year from the 3rd or 4th grade on, students have to review the operations with fractions before they can go on and learn the new material for that year. Most students have experienced converting fractions to decimals and converting terminating decimals to fractions, but many have not experienced how to convert a repeating decimal back to a fraction. Before we go over the procedures for these tasks, let's go over what it means to be a rational number as a review. A rational number is any number that can be written as a fraction. More specifically, a number that can be written as a fraction of two integers, so positives, negatives, and zeros, but no decimals in between. When we use these values, we can convert them to decimals, and those type of decimals can be written as either a terminating or stopping decimal or a repeating decimal. The chart at the bottom of the screen shows the unit decimals from 1/2 to 1/10. And if you look at the decimal forms of each, you can notice that ones like 1/2 and 1/4 and 1/5 end in terminating or stopping decimals, whereas 1/3, 1/6, 1/7, 1/9 end in repeating decimals that repeat the same pattern over and over and over again. These are the only type of decimals that can be written as fractions. Before we go over some examples, please note that I'll use the letter X to represent the word fraction. That way the word isn't taking up space in each example. So I'll start with an example that has a result that most people already know. We should know that 0.3 repeating results in a fraction of 1/3. But let's focus in on the process of how we get there. Now, one way to manipulate a value with a decimal is to multiply that value by 10 or divide it by 10 to move the decimal place to the right or to the left in the base 10 number system. So let's do that, and we'll do that to both sides of this equation so that we keep this as a true statement. So we have 10x equals 3.3 repeating. Now, how do we go from this relationship to eliminating the repeating decimal? Well, I cannot just divide both sides of this by 10 because we would still have a decimal within a fraction and we'd still have the repeating part. So what I'm going to do is I'm going to actually subtract this equality from the original equality to get rid of the decimal. Alright, and what that looks like is we have 10x minus x, and we have 3.3 repeating minus 0.3 repeating. And the result of that, it gives me 9x equals 3. We no longer have the repeating part of this fraction, and now we have a statement with only integers. So 9x equals 3 can be simplified by dividing both sides by 9 and ending up with x equals 3/9, or what we expected, 1/3. If we repeated this process for multiple single-digit repeating decimals, you would see that the same pattern happens over and over again. 0.5 repeating is 5/9, 0.7 repeating is 7/9, and so on. In some cases you'll reduce your decimal, like 0.6 repeating reduces to 2/3, but once you've done a few of these, you don't have to go through the whole process over and over and over again. Now let's take a look at 2 digits repeating as an example, like x equals 0.35 repeating. Now this time, if we just multiply both sides by 10, we'll still have one repeating value to the right of the decimal. So in this case, instead of 10, let's multiply both sides by 100. We'll follow the same procedure by subtracting our new statement and our original statement, finding the difference between those two things. You'll notice in this case, instead of 9 on the left, we end up with 99x, and again our repeating part does cancel, so we have 99x equals 35. Simply just divide both sides by 99 and we get x equals 35/99. So you should notice by now that the repeating pattern is that the number of repeating digits represents the number of 9s on the denominator of each of your fractions. Always remember to reduce, like 0.36 repeating reduces to 4/11 in situations like that. Also realize that that pattern would continue to go on. If I had 3 digits repeating, then I would have 3 9s on the denominator of my original fraction. The third and final example we'll go through is a slight variation of just a straightforward repeating pattern in your decimal. In this case, 0.1 and then just the 6 repeating provides a different twist to what we've been looking at so far. What we're going to do is for each digit to the right of the decimal that does not repeat, we're going to multiply by 10. So in this case, since there's only one, we will multiply both sides by 10. And you'll notice that I wrote the right hand side of this new equality a little bit different than you would expect, and you'll see why in a second. So we're going to go through the same procedure. We will subtract the top and new equality from the original, and on the left the same thing will happen. 10 minus 1x gives me 9x. On the right, 1.666 repeating minus 0.16 and the 6 part repeating. You'll notice I wrote that extra 6 first before the repeating part to emphasize the subtraction here. The regular 0.6 will cancel out, and then you have 1.6 minus 0.1 to give me 1.5. Now if I just go through the same procedures that I dealt with before, divide both sides by 9 in my result, I get x equals 1.5 over 9. Now hopefully most of your teachers have told you that you're not supposed to leave a decimal and a fraction together as a final result. Remember, rational numbers are a fraction of two integers. So the procedures for working through this type of a repeating decimal is a little bit more involved than the other types. What you do is you look for how many decimal values are to the right of the decimal and multiply by 10 for each one of those. In this case, since there's only one, we multiply the numerator and denominator by 10. In this case, we result in 15 over 90, so we could stop there, but we should realize that we can reduce that fraction. 15 actually goes into 90, and it goes in 6 times. So this fraction actually reduces to 1/6, which you may have recognized from the beginning of this presentation in the chart dealing with rational numbers. So that's it. You may also be asked to work with a mixed number, but you can just always pull the whole number part off to the side and just focus in on the decimal in these procedures. Thanks so much for watching. Continue to visit my channel for more videos on number sense and anything else in mathematics.